Welcome to the network management with ArcGIS, an introduction to the utility network. My name is Rami Myers. We've got Dave Crawford and Hussein Nasser up here, who will be walking through some of the characteristics and give us generally an overview of the utility network. We strongly recommend that if you've got detailed technical questions, to take them. There's two islands in the exhibit area. There's one around spatial data management and a second island near the solutions area specific for utilities. Both of them would be good for you to reach out. If you've got questions that they can't answer, we can find somebody here who can answer those questions for you. Utility network has been in production for a year. We're really excited about it. What we're going to do is we're going to cover at a pretty high level some of the characteristics and some of the feature functions, some of the data models of the utility network. So let's go ahead and get started. Hussein, can you bump me? So utilities have a lot of problems. They're certainly focused around core drivers, but they take up the entire enterprise. The utility network was specifically designed for better data modeling at a higher resolution, at higher scale, improved performance, and to be able to support adaptive solutions for all these challenges. Can you go ahead and advance? So understanding that the utility network is a framework, it's a platform. It's designed to give you that better data, across scales and resolutions that we traditionally haven't done in GIS, to provide additional visualization products such as schematics and 3D mapping and internals, and looking at your data from all different perspectives, to be able to give you enhanced analytics, to understand with deeper level of resolution the framework and network that your company supports, and to provide pervasive access, to give your users better user experience, to provide that solution across your entire organization, and to support the network analytics for all your business drivers. So Hussein, can you take us through some demos, please?
All right, thank you so much, Remy. Hey guys, thank you so much for joining us today. My name is Hussein, I'm from the Geodatabase team, and today we have a packed schedule for you guys to show you the capabilities of the utility network. The slide is loading up in a second. There you go. So Remy just defined this concept that we have built, this data set, this network management solution that we've been developing, and this will support the utilities for the next 20 years, right? So the next gen network management solution. So what we're gonna do here is go through the components of the utility networks, and we'll go through just talk about a little bit and then show a little bit of demo, and then hopefully go through all these pieces until we reach the part where Dave will talk about attribute rules and contingent values. There's new concept in the geodatabase. All right, so the first component of the utility network is like this domain network, which is this is the first component that represents the logical network, which you can think of as your water data or your transmission distribution. I mean, the electric distribution, electric transmission, your gas data, and then the domain network essentially consists of a couple, multiple feature classes that represents your network essentially. And what you can see in this picture is actually a utility network. And let's just jump and show you how this looks in the demo. So what we're going to do is if you go to the database here and then
hang on a second.
Yeah, do they? Oh.
It didn't cross over.
Oh, we have, apparently I have to stop presenting if I show that. How about now? Cool. So let's go ahead and just show the magnifier a little bit here. And then, so this is a typical data set that with a utility network in it, right? And then this is basically how the utility network look in your geodatabase. So if I go to the properties of the utility network, and the first component is we're going to talk about is the domain network. And if you have a domain network, you will essentially get certain number of feature classes with them. And these classes are device, junction, line, and assembly. And in this data, I have the Naperville data set, and we have an electric distribution domain, which has 4 feature classes, and another electric transmission domain, which has another 5 feature classes. Okay, and when you first create a utility network, we also give you a system domain network, that we call it, is called a structure network, which is used to kind of support your infrastructure, your domains, right? Think of these are the things that commodity doesn't run through. They're like poles or towers, things that supports your domain, essentially. Okay, so this is essentially the utility. This is the domain network. So let's jump, and I'm not going to go back to the slides. Just go through them, and the second portion here is we're going to talk about asset groups and asset types. So now that we have a number of feature classes in this schema, we have to kind of define my assets, right? So now we have all these assets that I have. How do I define them in these limited set of feature classes, right? So that's why we introduced these 2 concepts, asset group, asset types. Okay, and luckily with the geodatabase, we already have something called a subtype, right? So in the geodatabase, we have a class, and the feature class we have a subtype, and then that allows me to identify my asset in a certain general way. Okay, so that's the first thing. Okay, but now that I have the subtype, which is essentially we just reused it, we called it the asset group. Now, that wasn't still enough, because you will need more you need more information to identify your assets, right? So now I know my device is a fuse, right? I know my device is a fuse. I know my device is a valve, but what kind of valve? What kind of fuse, right? And that's why we had to introduce another field, which is just a regular field, but in the utility network, we treat it as like a kind of a system field where we can use to further discriminate this asset group into further information. So as you can see, let me zoom in here so you can see. Right? So you can see, for example, an arrestor. These are low voltage arrestor, medium voltage arrestor, and so on. Okay, so you have a circuit breaker, single phase, and 3-phase, and so on. All right, so that's essentially the asset group and the asset type concept, right? So now that we have these 2 concepts, right, the next thing we're going to talk about is the network rule, right? Now we have these asset group and asset types, and we have all my assets, but how do I kind of communicate between these 2? How do I create connectivity between my assets, right? And that is, we can do this through the concept of network rules. I know I'm going to show you an example here where I can only, for example, connect a medium voltage overhead to an underground underground medium voltage through a riser. I can only connect a 25-inch pipe to a 50-inch pipe through a reducer. It would be the other way around. But essentially, that's what example of a rule, right? So now that we have network rule, we enabled this across the platform, and editing follow these rules very nicely. And let's show you some editing to kind of explain this concept. So I'm going to go ahead here and zoom into a nice little area here. And then I'm going to create a new circuit breaker. And the first time I open this, it's thinking. So let's go ahead and create a circuit breaker. Right? And then I'm going to create a medium voltage line, okay? And then, so I'm gonna go ahead and create a medium voltage three-phase line. When I do that, you can see that it's the snapping icon. That means, hey, it's okay. You can connect a medium voltage overhead to a circuit breaker of three-phase. So because there is a rule that says, hey, you can actually do that, okay? But for instance, let's think of something that doesn't have a rule, like, I don't know, connector. If you do that, right, oh, actually a connector does have a rule. How about that? So let's think of something that doesn't have a rule. I don't know, this. As you can see, this line does not have a rule to connect to, so that you won't get this snapping behavior. And as a result, you get a cleaner set of data, because it will help you provide a more quality data, because we prevent you from making a mistake. That's why this is like the first line of defense, but we put other line of defenses. Even if you made a mistake somehow, data migration, or you appended, or you do calculating field, you will get into cases. And I've written a blog post about the different kind of errors in the utility network that you can get, and how you can go about fixing them, right? But all right, so now that we have talked about rules, what is next? We're going to talk about associations. Okay, so the concept of association is really interesting, and what happened is we had this requirement back in the GN where we have these little devices, we have this little compact areas where we have all these features, and we really need to create this connectivity between a junction and a junction, but the only way is to create this line, right? So we have to create this dummy connector feature line, and then we start creating all these features, which really doesn't exist in the real world, but you need somehow to create a connection between a junction and a junction. With this, the utility network, we actually introduced this concept of junction to junction connectivity, right? And this is called basically the connectivity association. So now you can actually create a fuse and an arrestor, and you can correct a connectivity association. So it doesn't have a shape, but it's a very optimized way of connecting two features together without actually drawing a spatial feature between them. Okay, so it's really cool. Let's show you how it looks like. Okay. I have it here as one of my favorite areas in Naperville. So if you go here, you can see there's a line coming up from the RMT, the circuit, going in here and then going back. But if I continue to zoom, something really weird happens. Like, what is going on here? There's like a bunch of lines just in the empty air, right? And the reason is, this is called containment. So there's a switch gear here that is the container of a bunch of switches and devices, right? But most of the users, especially who are working at the higher level of the map, they don't really interested in rendering and seeing these low-level small devices. So it says like, you know what, hide them. This is a containment view and we hide these. But if you really need to see them, we allow you to see them using this concept of display content. And if you do this, suddenly you can see these features now. But still something is going on, right? Because these are features, are they really connected to each other? Yes, they are. And this is the concept of the connectivity, essentially. This is the connectivity association. They are connected together. But now, it's like, when we first released this with the alpha utility, people came back and says, okay, I really now need to see those associations. So what we did is actually we shipped this concept of kind of visualizing the association. It doesn't exist, but you can use the view association button here to actually just render these as a graphic very fast, right? In this extension, just show me how is this stuff connected to each other. All right, so that's essentially in a nutshell, the connectivity association, containment, and also structural. That's another type of association, right? Brings us to the next point, the best thing ever in the utility network, which is called the network topology. Okay, so before we talk about network topology, we need to talk about this concept of the features that we have. So we've talked about, we have a structured network. I have a domain or domains, right? I have one or more. And these I have classes and features and asset groups and asset types, and all these features represent what we call the feature space, right? So these are what users interact with. This is the fuse, transformer, valves, and pipes, and all this stuff, right? But there's another side that you guys don't see is the network topology. What the network topology does is takes all that stuff, the pipes, the lines, the polygons, and the valves, and everything, and it converts them into the backend into just two things, junction and edges, right? It will be very compact binary graph of junction and edges. Everything you see here, all these features become junctions and edges on this network topology that we call the network topology. So the network topology represents the graph that corresponds to these bunch of features. That's what allows us to do the cool analytics in the utility network, the high performance analytics. Now, this presents us with another kind of interesting thing, right? If I edit my features, my network topology is out of date, right? Because we have built it once, and all these features now converted into a junction and edges. But now I edited something here. How do I let the graph, hey, by the way, I changed something. Go ahead and build it. And this is the little guy that allows you to do that, which is called validate. And if you have noticed, any edit that I make is followed by what we call a dirty area, this purple rectangle, square, yeah. And this is essentially what we will use to identify the changes that happens. In the GN days, we always did this validation with every single edit, right? In this, we use like a later approach to validate, okay? And then keep those two views in sync, okay? So network topology, and then the feature space, okay? Next thing we're gonna talk about is the subnetwork management, okay? And it's one of the biggest and more powerful features of the utility network, okay? What you see right now is two feeders, two circuits in the utility network, and these are identified as a single line feature, which we call the subnet line. And we put a lot of good information, like the number of customers, the total number of load. This is now possible because of the subnetwork management. Okay, so what is subnetwork management? So we have provided, as we said before, these domain networks. Okay, so we have a utility network, and then we divide it up into domain networks. Okay, and then what we saw is missing is we need kind of, even in the domain network, we need these little segments. We need this mini networks, these sub-networks to identify like different portions of my network as these sub-networks, right? And that's why we invented the concept of sub-networks. And the simplest definition, in my opinion, for a sub-network is this segment of my network that has a starting location. It starts somewhere. It starts with a certain asset of type asset group, asset type, right? Because remember, everything goes back to this asset group, asset type. Asset is identified by these three things with a feature class, right? And then once you have this, right, you can identify the starting location, or where does this subnetwork starts. And also, it also identifies where does it end. How does it end, actually, okay? So that's how a definition of a subnetwork. And also, what does it include, right? Does it include these asset groups? Does it include these asset groups? And so on, okay? So this definition that we talked about, the starting location, how it ends, what does it contain, is all stored in this concept that we call a tier, okay? So tiers are part of the domain network that defines this subnetwork. So here I have a medium voltage tier, and we can see that this is the valid network subnetwork controllers. Where does it start? And these are the valid devices, and these are the valid lines. And we can go up until how does it stop? What conditions stops this subnetwork? In this case, if you see a device that is open, stop the subnetwork, all right? And this is exactly how this subnetwork is configured. So if I zoom in here, the red subnetwork number 3, if I click here, and what we have is the circuit breaker 3-phase is the start of the subnetwork, and we call this the controller. The subnetwork always starts with a controller, okay? And how it ends is, you can see that it terminates here, right? I'm gonna zoom with the magnifier, and it also terminates here. So what's going on? Let's try to zoom in, actually zoom in, and take a look at this device. And if we take a look at this device, we can see that it's actually, that's true, it is open, okay? So let's go ahead and do a quick trace to prove that this trace actually stops there. So I'm gonna trace subnetwork number 3, which is the red subnetwork, and you can see that the trace actually stops here, okay? And it is very powerful because it goes through here and goes all the way there and comes back. I don't know if you see my mouse. I think you do. Okay. It goes back and then comes back and it stops right here because we told the tier, hey, this device is open, please stop the trace right now. And as a result, accumulate the total number of customers and total number of load and store it in this subnet line class, which is a single feature that contains all the information about the subnetwork. All right, guys, so let's go ahead and do a little workflow, a very popular workflow on the electric utility, which is called a load swap. Okay, so I'm gonna go ahead and do a load swap. I need a version to do that because I'm gonna do some editing. So go ahead and do a load swap, then change version. And what we will do is basically we will close one switch that is open, and then we open the second one. So what will happen is you're gonna see all this red portion, it's gonna belong to the blue circuit, okay? Let's see if we can do this, right? And I am going to cheat and say that this, okay, click identify in the wrong location for some reason, okay, anytime soon. All right, there you go. So this device is closed, right? And this device is open, right? I'm gonna flip them. That's what I'm gonna do, right? So what we're gonna do is click on this, I accidentally cleared, attribute, flip it to open. There's a dirty area. Remember, guys, the network topology needs to be updated. We need to let it know that something changed. So I'm gonna close this device now. And now this is the most important thing. I have to validate my topology. And if I do validate, the network topology will rebuild this with the new topology, which is now the trace, if we think about it, the trace subnetwork 3 should stop right there if we're lucky. Oh, we should also save my edits, but it shouldn't matter. It's okay, so what this does is it takes the new topology that we just built, and we're gonna do a tracing analytics on top of it. Did we lose connectivity there? Did we lose network? No. All right, there you go. Oh yeah. Should have saved my edit there. Okay. So this is currently a bug that we're working on, that if you did not save your edit, which is totally a bug obviously, but if you don't save your edit, this trace will slow down essentially. But now, shh.
You're not supposed to tell them that there's bugs.
Our software is perfect, guys. Okay, so as you can see, the trace stopped here, and now let's go ahead and update the subnetwork. So if I update this subnetwork first, let's just go ahead. All right, so if I do that, let's go clear and, all right. So now if I trace my circuit number 1, you can see that circuit number 1 should stop. It's faster now. Told you guys. Okay. And then if I refresh this, hopefully, it will tell me that it's dirty. Okay, there you go. So now I'm going to update both subnetwork. I'm going to update subnetwork number 1 and update subnetwork number 2, which will change the two features that you saw, the red circuit and the blue circuit, which will basically start recalculating the number of customers and recalculating the new shape of the subnetwork, and then will tell you the new results, essentially. Okay, so we're done. Subnetwork number 1. Let's go ahead and update subnetwork number 3. And that will, again, we'll run trace for subnetwork number 3 and then calculate all the stuff. So I don't know if you remember the old shape, but now if I go, as you can see, the new subnetwork is now subnetwork 1 is bigger, subnetwork number 3 is smaller. And if I identify this thing, I can see that I have less customer. I have 71. Used to be, I think, 100 or so.
133.
Right? Yeah. So now, so that's our subnetwork management in a nutshell. Last thing we're going to talk about before we jump to Dave is diagrams. Okay, we did the tracing. We talked about subnetwork management. Now the diagram concept. The diagrams is we have baked in the schematic, the ArcGIS schematic, into the utility network. So now once you have basically, what do you have? The subnetwork management, and once you have a utility network, you can actually create diagrams out of this. So I have actually created a diagram beforehand, and what I'm going to do is actually just show you that diagram that represents circuit number 3. So if I open this diagram here, you can see that this little neat diagram represents my subnetwork that I just updated, right? This is the start, and it looks very neat, and like it will show you where does its subnetwork stop, and this is like basically where the tie switch is, essentially like where two subnetworks meet, essentially, right? Not necessarily circuits, but any subnetwork can terminate in a single device, and this device is called, we call them the tie switches in electric, and we call them the boundary devices in generic term, okay? And not only that, you can actually interact with this thing. You can select and say, hey, show me where's this device at. If you select that, show me in the spatial, it says, hey, that's your device right there. Okay, and I'll show you something that is not a point. Let's apply that. Then you can see, for example, that's the line that we have selected, and so on. And for example, last thing before we end this is, hey, where's this tie switch? I want to really see that, okay? Then if you go there, you can actually see the tie switch, and that's the new tie switch that has been as a result. And with that said, I'm gonna shift this back to Dave. Thank you so much, guys.
That was 40 minutes worth of demos in 28 minutes. That is impressive.
Hey, all right. That was really good.
So, Hussein gave you there sort of the broad overview of the utility network data set itself, sort of what are the bits and pieces of it all. But as we all know, network management, if I don't drop my mic pack, is more than just the data set itself. It's also the UI, the UX, the interaction, the tools that are available to you, the things that help you get your work done, not just effectively, but also correctly. So one of the biggest complaints I've heard over the years of being here, working through the geometric network and all of our 10.2.1 patches and all of our fun life that has been, is why do you guys let us make bad data? Is probably the most common thing we ever get told in the geometric network. Of course, that thing was just a wide open world where you could do whatever you wanted. So what I'm going to show now are two things that we've introduced in ArcGIS Pro specifically in terms of the UI interaction with them and the editing behaviors. However, both of these concepts are actually available across the entire ArcGIS platform. So there's nothing I'm showing you now that doesn't live at the database level itself. I'm just going to show it through Pro because the tools in Pro are smart and they're built to work with these things. So the two concepts, the first one is called attribute rules. And I apologize for people on the left of the room. I'm not going to look at you very much because my mic has shifted on my shirt. And if I look to the left, I think it goes quiet. So the first concept is attribute rules. What are attribute rules? These are things that you configure in your database that actually control what happens as you edit data. When I create a feature, are certain fields calculated automatically? Is there asset IDs put in there automatically from a sequence that I've created in my database? Perhaps when I update features, I want some other action to happen. Perhaps I need to notify another feature that it needs to be updated at a later date. That is all accomplished through attribute rules. There's 4 general concepts of them. There are what are called immediate calculation rules. There are constraint rules. There are batch calculation rules and validation rules. Constraint rules will, at the moment that you edit, throw an error if you violate them. I'll show you a couple quick examples, but one thing I'm not going to get into in this particular session is the configuration of all these things. They are a complex thing. The purpose of putting them in this session is just to round out the idea of utility management and network management within the ArcGIS Pro and ArcGIS infrastructure and ecosystem. The session directly after this in Mesquite C,
Yeah, we're on C.
hosted by this gentleman, Hussein, and Sang-Ho, who's back there probably hiding underneath a rock right now.
Hi, Sang-Ho.
They will be hosting it, and they will talk in a much greater detail about the configuration of these rules, how you set them up in your data, and how they work. I'm just going to show you sort of the utility perspective of all that. So we'll take a look at a couple rules, sort of simple examples. There's a view in ArcGIS Pro that allows you to configure all these things. And all of these rules use an expression. Jesus? So, is it me? Am I stepping on cords? So all of these rules can be configured either as a straight expression. So for example, a calculation rule could just say, to this field that I want to go calculate, set the value equals to this number. Or you can use this language that we've built into ArcGIS itself called Arcade, which can create if, then, else statements and a little bit more complex programming to determine what you want to happen. So right now I'm looking at all the constraint rules that I have created on my device feature class, which Hussein talked about. Now what I have done in here is I have created different rules for all the different kinds of asset groups and asset types that I have in my data. For example, this rule, fuse phases current single phase, what this script does, and I can actually show it out here in a little bit more of a clear, readable way. And I don't know that cool zooming trick that Hussein knows, so unfortunately, that is as big as I can make it right now. But what I can actually check is I can say if the value that is being entered into my phases current field matches A, B, C, or de-energized, then we're okay. You can allow the edit to continue. If someone has taken this single phase device though and put AB on it, well, that's not right. That is bad data entry. So you actually want to raise an error at the moment they do it. That is what this arcade expression will do. This return Boolean of 0 is the false or the error case. The other way, it's okay. So you can actually see that we wrote this rule interestingly. Developers might argue it's backwards, but we do the not cases. So if the phases current is not A, not B, not C, or not de-energized, return the false. If it's anything other than that, it is one of those things, therefore return true.
We're engineers.
The constraint rules will actually prevent the edit from happening. So I'll show an example of that when you violate a rule, how it actually prevents you from doing the edit at all. How do I prevent people from putting bad data into my system? I create constraint rules that doesn't let them put bad data into my system. There's another kind of rule in here, which is the validation rule. The reason I go constraint to validation is because they're sort of analogous rules. Validation rules are also designed to check that the data being entered is correct. The difference is that validation is a process done after the edit is complete. So you'd actually allow the edit to go in with incorrect information. Then when someone runs their evaluation through the validation server, which I'll show you how you interact with that, then they would see error features get generated. Those error features could then live in a version where a QA person could go in, take a look at them, clean up all the errors that have happened for that work, and then reconcile and post that version up into default. At that point, again, how did we prevent you from putting bad data in there? We've identified these things. We're creating error features. We're letting you know up front that there is something wrong with this data. It violates a rule that you've created. Again, the same rules apply. It is an arcade expression that you can put in here. You could also just say returns false or something if you really wanted to mess with people in your organization. That'd be kind of mean, but you know. And one of the cool things about the arcade language, and hopefully people will get into this in the more detailed ones, is there's a couple built-in functions, such as domain name, which actually lets you go out to the field, find the domain, and compare the coded value descriptions instead of the numbers. So if you don't know if it's number 8, 9, 10, 11, but you know the description of it, you can still write a rule that makes sure that it uses the correct values. The next kind of rule we're going to look at are these calculation rules. Now, calculation comes in two flavors. There's the immediate calculation rule. What does that mean? It means that the moment I do the edit, that calculation rule will be fired. So there's two interesting ones on my device class that I have here, which is date installed is null, and the asset ID is the next value. Date installed is null. All that's doing is saying that you are creating a device in your utility network. Odds are it's been installed if you're creating it in your utility network. And in my world, I'm saying if you don't give me a date, I'm setting it to today. And the way that that rule works is right up here. And so we check as it goes installed. We say if the proposed installation date is null and the date installed is null, set it to now, which is another function inside of Arcade, inside of JavaScript, that returns the current time in UTC time. So make sure you get your calculator out and figure out what your time zone is to make sure that it entered correctly. And the other one there was the asset ID is the next value. What this actually allows us to take advantage of is sequences in the database. So you can run the geoprocessing tool, create database sequence, name it whatever you want to name it, and then you can leverage those sequences in your Arcade scripts to generate unique identifiers, to generate some bit of information that is important to you in your organization. The way you handle that is, again, it's just one of these keywords, next sequence value. You provided the name of the sequence you created, and then it will return you the value. I'm not going to go into that. And then I don't have any batch calculation rules here. But the idea of a batch calculation rule is it's a calculation for a field that is expensive or it has some real cost associated with it at edit time. So you don't want the person editing to always have to eat the cost of taking that calculation, especially if it's some complex calculation. Instead, the feature itself gets marked as requires calculation. And then when you evaluate the rules using the validation server, we will run that calculation for you on the back end, write that back into the feature, and then the user sees it. But they are not forced to eat that cost as they go. Every organization is going to have a different use for that. Some people will go heavy immediate calculation. Some will go heavy batch calculation. Some will find their sort of niche in the middle of that. And that's OK. It sort of is whatever you feel in your organization is the best use and the best division of labor there is perfectly fine. Maybe you want everything to go through QA, QC and have all the error features removed before these calculations happen. So you want to allow the person to go through the validation workflow first, get errors, clean them all up, and then run that batch calculation to write all of those values that mean something to your actual organization but cost a lot in order to calculate. Maybe it's a very expensive load flow calculation or something. So the next thing I'm going to show before I dive into actual software here and show it to you is contingent values. And so this is the idea that fields do not live independently on a feature class. Fields theoretically are independent, but for example, in this case, I have a pole height check set of contingent values. On my pole subtype in my structured junction feature class, I have built all of the permissible combinations of values that can exist. So for example, on a wood pole in my world, a medium voltage wood pole, the highest it can be is 65 feet. I find if they get higher than that, they tend to bend over, and it creates no end of headaches for me. So in this case, that's how I've configured it. However, concrete or steel poles, which are just ornamental, can be any height that they want. I could continue to refine it by selecting from that coded value domain applied all of the height values that are valid in that combination of fields. I've only added 3 fields here. You could add 4, 5, 6. It can be as big a field set as you want. The only thing to keep in mind is as you add these kind of rules, the more fields there is, the more combinatorial things you can do, the bigger your matrix gets, the more this view gets a little bit confusing. So you got to sort of make sure that you're using contingent values that make sense. Coming in future releases, we're going to build tools that help you with that. Things that will go through your actual data and populate this based on the combinations you have already in your data. That way we seed you. Then you can look at that and say, oh, you missed 2 that I just don't have yet, but I need. You can add them in. So how does that help us? That was a lot of words. So we're going to look here. And so I have my utility network data. And I want to look at a specific area. So I've been told by my field crew that they believe that a pole information is incorrect. So I happen to know it's this pole. They went out and inspected it. And they said, hang on, we got a work order report that said that this pole is 105 feet tall. We took a picture of it. That's not 105 feet. In fact, that's like 35 feet. So what we could do is, what that first would tell me is whoever initially created this thing forgot to put the constraint rule in place in the first place, or forgot to set up their contingent values properly, and they were allowed to create a bad combination of things. So by selecting that pole and looking at its attributes, you'll see that I have these yellow boxes all around the fields where contingent values apply. It highlights all of the fields, even if they are not in any violation, because the combination of them becomes the violation. If you hover over it, it'll actually tell you if I hovered smartly. There it is. Selected values do not satisfy one of these things, and it actually tells you what the name of the contingent value field group that I built is called, the pole height check. Now I happen to know it's because this is a wood low voltage pole, and it cannot be 105 feet tall. So you'll notice when I actually pick the drop down, the domain on the pole height is huge, but I'm only getting 3 values. That is because the UI is actually limiting the things that I see based on what are allowable configurations, based on the other things I've picked. You'll notice there's also this partial matches, and what that is telling me is that on the asset type of wood, there is actually 4 more heights that apply. So maybe my material is actually what is wrong, and it is not the height itself that is wrong. So it starts to give you those clues that, oh, maybe I just missed something. Maybe this is a different kind of pole that I didn't factor in as I went through my configuration. But in this case, someone took a picture of it. I know it's a 35-foot pole, so I can apply it. There we go. So that is how contingent values really help the editing experience. They limit all of the pick lists you have, the number of choices that you can make. And again, we're just trying to help you, your users, pick the correct data so you don't have bad data in your network and I don't get yelled at for the next 15 years of my life about why let you make bad data, as if I let you make bad data. I wasn't alive when you guys built this stuff. And the last thing I'm going to show is using those validation rules, because I think they're pretty cool. They show sort of the idea that we can create errors and make sure things are correct. So the first I'm going to do is quickly here, I'm just going to show you some of the calculation rules, the immediate calcs, because they're kind of interesting. So if I was just to grab a fuse and create a fuse, and then look at the attributes of said views, what you'd actually notice is that the asset ID was populated. That was using that sequence value. That's just executing that immediate calculation rule. So the second I create the feature, it runs that rule, it creates that calculation. If I had set that as a batch calculation rule, this would be the default value, in my case null, and all the way down here, we would see a validation status that said calculation required. And that would tell the system, oh, you got to go calculate something on that device that was just created. So I don't actually want to use that feature I just created. For this little example, I show, so let's say I wanted to create a single phase transformer, and I was just going to create it right there. And then I was going to zoom in enough that it doesn't disappear because of my scale suppression, because I built a smart map. And I want to connect it to a medium voltage line. So I go here, I pick a medium voltage line, and one thing you'll notice is that on my phases here, when I have a single phase underground line, again, the contingent values are there. I only see A, B, or C to pick. I don't see A, B, B, C, all these other combinations that just don't apply. I could click it and create it. Now, in my error inspector, which doesn't want to stay open, there it goes, I can actually go in here and I can run evaluate. So this is that process that's saying, what I actually do is actually doing it by the extent. So it's saying in my extent that I'm looking at right now, are all the features that are marked as requiring validation valid? So in this case, one of them is not. So I can actually look at this error feature, and I can go all the way across here. I can just open the pop-up, because that's a much easier way to look at it. And I can actually see that the reason I'm getting an error, it has an error number. This is defined in the validation rule itself, so you can create your own error numbering scheme. And I get a nice message. And again, this message is defined in that rule. It says, a single phase overhead transformer requires that the feature be attached to a pole. And I would say, oh, right, I forgot to create a pole there. So that I could go back. I could create my pole, which would not be unknown. I could make it as like a steel pole with a height of something else and drop it in there. We'll see. So this is what happens if you violate your contingent values. And I just realized I put myself into a corner that I can't get out of. So ideally, I would be able to create the pole, make the attachment association that Hussein had talked about, rerun evaluate, and the error feature would actually go away. If anyone wants to talk about that stuff in more detail, I'm at the island, the Spatial Data Island, next 2 days. Hussein has the session right after this one. You can find all about attribute rules and all that fun stuff. Yeah, let's swing on by. Okay. Thank you very much.
So a couple of quick things before we wrap up. One, we mentioned the geometric network. And let me reinforce, it's not going away. ArcMap is not going away. Geometric network is not going away. The utility network is the level of effort that development is focusing on. But ArcMap and geometric network will continue to persist through upcoming updates. So let's talk about the roadmap a little bit. So right now, 10.7 is scheduled to be released in a couple of weeks at the end of March. So a lot of the feature functionality that you saw in this demo is in 10.7. We covered contingent attribute values. We covered the enhanced attribute rules and the batch validation. One of the things we didn't cover is the ability to add your dimensions to the utility network. So have your dimension characteristics in your utility network. What we're working on now is we're working toward non-spatial elements for telecom and certainly for things like SCADA items and AMI. We're working on runtime. Those two things right there are pretty heavy lift, and they will probably go somewhere into the future, so we don't have an actual release date specifically on that. Yeah, can you go ahead and advance? So let's talk about how we can learn more. There's definitely some resources that are out there on the web. some opportunities to have deeper understanding into the management. The live training seminar that Hussein and I did earlier this year is a great resource. Go ahead, Hussein. Plus, there's some great classes this week. As Dave and Hussein mentioned, and actually I missed it from my slide, I strongly recommend you attend the attribute rules using Arcade in B.
Yes, Mascade B, and there is another one at Thursday, 3 o'clock, where I will be just working with how you can author attribute rules from scratch, like just the authoring experience and working with them as well. So Thursday, 3, check it out.
So we'll go ahead and leave this slide up for the moment. The other thing I'd like to ask you is if you have the app, please rate our session. Let us know how we did. Let us know if this adds value to the conference. Do we want to do this again next year? And if you don't have the app, get the app. It's a cool product. So I'd like to open up for questions. Does anybody have questions while we still have a few minutes? Yeah.
Can you go back 2 slides to the one that had the links on it?
Can you go back 2 slides to the one that had the links?
No, one more.
One more. There you go.
That one. That's an easy question.
That's the easiest question I'm getting all week.
Yeah, go ahead.
What's the support for like mesh networks?
So the question is support for mesh networks.
Hussein?
Support for mesh
Turn your mic on.
network.
So
Oh, yours is on.
yeah, so
Yeah,
like
so-
as a tier.
Yeah, so mesh network is currently supported in the utility network since the first release. Right? You can build mesh networks with what we call the hierarchical type of tiers. So we talked about tiers, right? But I didn't go through the deep level of tiers where are 2 types. Partitioned, where the tiers that we talked about, the subnetworks are kind of sequential. They follow each other into ranks. Whereas hierarchical or mesh, essentially, is they kind of overlap on top of each other, where you can have a feature belongs to multiple subnetworks. This doesn't happen in partition.
Can you jump to the training classes?
Training classes.
So yeah, the advanced class on
Yes,
Thursday
Yes.
is a great class to go to ask Tom Brown about mesh networks.
100%, yeah.
Any other questions? Yeah.
How to configure the roles for the big network? Like who can configure the network rules, who can configure the attribute rules?
Right. So the question is, who has the authoring capability to configure the rules?
Yes, so we have the concept of the utility network admin, and this person is the one who created the utility network. They can add rules, they can configure the UN, they can disable topology, they can add asset groups, asset type, they can do pretty much anything in the UN. And this is the only person that can configure and add rules, right? And add rules currently is only supported as a client-server operation, so you have to connect it to the database directly through this user and through the portal dataset owner. If you want to learn more about these 2 differences, the database owner and the portal owner, please visit us up in the geodatabase island. Ask this question. We're gonna tell you more about it. The UN kind of have 2 owners, and we can dive in deep into that when.
So
we have this
Hussein, I think I recall development is working to be able to open up an administrator group. Am I correct in that?
Very good question. So for the. What was that?
That was
There's a demon behind us. Sorry.
I was like, okay. So yeah, so very, very good question. So the owner of the UN is the one who created the UN and published it. Okay. Also, any member of the administrator group can also make these changes, certain changes, not all of them, obviously, but yeah.
So is that available now? I thought that was going to be in a future release.
No, no.
Okay, so it'll be in an upcoming
Yes.
release.
Yeah.
You'll have the ability to have additional owners as opposed to one owner,
Yeah.
the way that the
So there will be another ability that we're currently working on is to transfer or update the portal owner of the utility network from one user to another one, and that's we're currently working on. It's like if a user left the company, we want to like take the UN and literally make it owned by some other user, and that's something we're working on currently.
Okay, any other questions? Yeah.
Is there still any need for a data reviewer? It seems like this could replace.
So the question was, is there still any need for data reviewer? Because this seems like a replacement for it. Data reviewer still has a place in the ecosystem. It will very much depend on sort of your individual use. You're welcome to come talk to me afterwards about it. There will be some cases where perhaps it is no longer required. There will be other cases where it is still absolutely valuable. We're working directly with the data reviewer team to make sure that our goals and our user experience very much align, and it's just a matter of delineating where that line is as to what lives with us and what lives with them. But it's very much coming into a single, they're using the same error inspector we're using. We're trying to sort of keep the same infrastructure behind it all. Data reviewer just has their own sort of set of rules and things like that.
I think it's all, okay, go ahead.
Do the validators and the rules take effect only in the ArcGIS Pro client, or do they take effect in post-feature rules?
So the question was, do the validation rules take place only in the Pro client, or do they take place elsewhere? So the validation actually takes place on the server, on the back end. So any client calling into it can execute those. There's actually an evaluate method that lives on top of the validation server itself at the REST level. So everybody calls into it. I demo stuff in Pro because Pro has an editor that's sort of built to consume it all up front. But through web apps or anything else, you can call evaluate, you can get back your results, you can display all your features, you can show the error features. That's all there.
So following up this question, yes, you can actually do that. And I'm going to show up if this comes back. Yep, there you go. So this is the REST endpoint call to evaluate, which Dave showed from Pro. Pro just simply calls this REST endpoint, okay? And when you fill this information, you can actually call it from a JavaScript client or runtime even, right? You can actually do that, yes.
Yeah, none of the things that I showed are specific to Pro at all.
No.
Even the immediate calc rules. If you're going through your service, you're getting to your database, once you edit it, the edit goes in, they're fired. Regardless of if it's on just a local enterprise geodatabase that's running non-versioned, running traditional versioning, branch versioning through a service, they all hit the same code paths.
I assume for the demo that Sam was doing, that was going through feature service.
Yes, all of our demos are going through feature service. The utility network is only supported through feature services, so all of our demos go that way.
Okay.
So I think we have to let Hussein get to the next course. I think Dave and I can hang around for questions. If anybody else has any questions.
It says 5:30.
What?
Oh, we still have time?
Yeah, we got plenty of time. What are you talking about?
All right, one more question, please, sir.
You were talking about hydro network. What kind of hydro network?
So you can have water distribution, stormwater, runoff. Go ahead.
We're still working on a true hydro network solution is being worked on sort of as we speak. But right now, outside of just modeling a hydro network as a utility network that's very simplistic, there's nothing directly that is hydro support, if that makes sense.
Thank you.
Yeah.
Anybody else? Cool. Thank you so much. We really appreciate it.
Thank you, guys.